resilient. They're adaptable, and there's an underlying, unspoken oftentimes idea is that you can throw a lot of management schemes at them and they'll be fine. They'll be okay. They can take high mortality rates and they bounce back. You know, make a mistake with a grizzly bear population and it's with you for decades. Make a mistake with a wolf population and it's with you a couple years. And that is an underlying assumption to most management decisions. Again, I'm not taking a side on this thinking, as the previous speaker spoke to. We need to have a general debate about this. We need to talk about it openly and decide what we want to do. But for the National Park Service, the debate's over. We're managing for natural. So we want to consider these type things because we have discussions with the surrounding states, not Washington, Oregon, but Idaho, Montana, Wyoming, about boundary issues. And what happens when a wolf lives 99% of the time in the park and it steps out for a day and it gets harvested. And so those conversations have been very productive, actually, but we as a Park Service have to present our policies to the states, which present their policies back, and we have the discussion. So this is what this is about. So through time, pack complexity increases. This is mean age in a pack, increasing for quite a while post-reintroduction. And then this is the percentage of older wolves. So this belies something that's an assumption, and the next series of graphs are really going to bring this home. But this is this assumption that all wolf populations are right in here, 1, 2, 3 years of age. And Scott said it, they don't live long. The average age of wolf death in Yellowstone is around 5 to 6. That's average. And ours is mostly driven by natural mortality. 65% of our mortality is wolves killing wolves, as Scott showed in his graphic. When it's natural mortality, it's usually wolves killing wolves. So they don't live long. So this bodes well for high harvest if you're a manager. They bounce back. They deal with it. That's the underlying assumption. And what's interesting about this is these, when I talk about this upward pressure, these multi-generational animals, the extra animals in the pack, it increases rapidly for about 4 to 5 years. So pack complexity really increases. This is based on the age of the pack, not time period. And then it levels out, but it's still, this is kind of a break point, but complexity is increasing up to 10 years. And so you go into wolf population, a huge rationale for wolf control. A lot of wolf controls occurred in the north, Yukon, Alaska, other places, British Columbia. And the argument is, as soon as you stop killing wolves, within 2 to 3 years, you have as many wolves as you began. This metric has not been applied to those data, social complexity. And so again, I'm not allowed to make value judgments outside the National Park Service. I do talk with Bridget. This is not a decision that's based on entirely just what are the results. It's based on what society decides, a debate that we need to have openly. But pack complexity takes a while to sort itself out. And so this is a picture. This is how it shows how hard it is to ID wolves. You can tell these are pups, mostly because they're messing around. They look similar size to some of these adults, and this is, you know, the alpha female worried about what the pups are doing back there. You know, that's anthropomorphizing. That's not correct.